So today we get to talk about complex conversions. I mean, this is real problem solving. I mean, we're no longer using a cookie cutter recipe for problem solving. We're saying, look, do you know how to solve problems? So that's the whole key here in chemistry. You need to be able to solve problems, and it's not like a memorization, where I memorized how to solve a problem, or you look at a problem and say, gee, I don't remember exactly the exact steps to solve it. No, this is when you read a problem and you say, I know exactly what I'm doing and I'm going to solve this problem. It's a different type of attitude. And so this is what I want you to have for solving complex conversions. So let's get started. Two cars compete for fuel efficiency. Car A gets 40 miles per gallon and car B gets 16 kilometers per liter. Which car is more efficient? So we either have to convert the car A, the 40 miles per gallon, into kilometers per liter, or we can convert the kilometers per liter into miles per gallon. So what we need to do is start off with either one or the other. Let's start off with kilometers per liter. So we're going to have 16 kilometers per liter. Well, you should know that in every kilometer there are 1,000 meters. Every kilometer has 1,000 meters. And you should know that there are roughly 1609 meters in a mile. 1609 meters in 1 mile. Notice that the kilometers drop out, the meters drop out, and I'm left with miles. And I have miles per liter. I want to compare, so I need to get miles per gallon. So we need to convert liters into gallons. And you should remember that there are 3.78. Let's see here. Liters has to go on top so it cancels out. 3.78541 liters in every gallon. Notice the liters drop out. Now my units are miles per gallon. So all we are left to do is just a quick calculator problem. And so we have 16, and we multiply by 1,000, and we divide by 1609, and we multiply by 3.78541, and we get 37.6. So 37.6, and then that's miles per gallon. All right. So that's car B, and car A is 40 miles per gallon. Car B is 37.6. So clearly car A, since it's got a greater mile per gallon, it's more efficient. So you can solve any problem being presented if you know the conversion factors. Any problem. So let's have some fun with this. Let's talk about cigarettes. I mean, people smoke cigarettes all the time. They know it's bad for them, but hey, let's just do a calculation. Okay, so a cigarette contains 15 milligrams of tar. Okay, now this tar that they smoke, it sticks to the lungs. So when it sticks to the lungs, it prevents the lungs from opening up and getting more oxygen. And there are 20 cigarettes in a pack. See, look at all these conversions that we're getting. 15 milligrams of tar in one cigarette, 20 cigarettes in a pack, and we're going to smoke 2 packs a day for 10 years. And we want to figure out how many pounds of tar are going to be contained in the lungs. You know, what's our goal after 10 years? How much tar can we cram in our lungs? Now, typically a smoker's not going to be, they're not going to like start out smoking and think like that. But in all honesty, let's just say what really happens. So notice that we're going to go for 10 years. we are going to figure out for 10 years. So let's give us a little bit of room here. So we're going to have 10 years. And in 10 years' time, we know that there are, let's see, each year, we have to put year in the denominator, there are 365 days. Okay, so that gives us how many days? But you notice that period says we're going to smoke 2 packs of cigarettes a day. So each day, we are going to smoke 2 packs of cigarettes. So, just cough thinking about it, 2 packs of cigarettes. I mean, not just one, but 2 packs. I mean, the average smoker, it is not uncommon for the average smoker to go through 2 packs of cigarettes every single day. And so each pack of cigarette each pack contains 20 cigarettes. And each cigarette contains around 15 milligrams of tar, somewhere around there. I mean, you can smoke the lights, the lighter brand cigarettes, and then you'll get a lower grade tar, like a 9 or 11 milligrams per cigarette. But usually most cigarettes are anywhere from that, that 12 to 16 range of, that's how many milligrams are in each cigarette, milligrams of tar. Well, we're not wanting milligrams, we want to get full pounds. We want something that we can relate to. And we should know that there are 1,000 milligrams in 1 gram. And that there are 1,000 grams in 1 kilogram. Well, now we use our kilogram mass weight conversion, and we know that there are 2.2 pounds 2.2 pounds for every kilogram. Now look at that. The years, the days, the packs, the cigarettes, the milligrams, the grams, the kilograms. You see, every one of these, it seems like a complicated problem, but when you just write it all out, once you know the conversions and you just flip the ratios one way or the other, then you can solve the problem really easily. So all you have to do is flip the ratios. So this is exactly what we're going to do all year long. We're going to use brackets to solve problems. It is real important that you understand the fundamental process of the bracket notation. We will use this method all year long. Now, we won't use these same conversions, of course, all year long, but it's the logical approach to problem solving. So make sure you understand it. So let's get our calculator out, and we have 10 years, and there's 365 days in a year, multiplied by 2 packs a day, times 20 cigarettes in a pack, times 15 milligrams per cigarette, and then we have to divide through by 1,000, and divide through by 1,000, and multiply by 2.2, and we get 4.8 pounds. 4.8 pounds. I mean, they're smoking 2 packs a day for 10 years. It's 5 pounds of tar almost. Oh my goodness. Can you imagine carrying around 5 pounds of thick tar inside your lungs? Oh my goodness. So, yeah, that's crazy. It seems crazy. But, it's a perfectly valid calculation. That's what you get, if all that tar gets into your lungs. But, the one thing about this is, in part C, let's expand on this problem. I mean, in order to get that 5 pounds of tar, that 4.8 pounds of tar, hey, you paid for that. It cost $7 a pack. So, hey, how much money did it cost to get those 5 pounds of tar in your lungs? How much money does it take to get 5 pounds of tar in your lungs? Well, again, we have 10 years, and we started off the same way. And each year, there are 365 days. Right? 1 year, or yeah, 1 year, there's 365 days. And each day, they are smoking 2 packs. 2 packs of cigarette. Each pack costs $7. I mean, $7. That's a chuckload of change right there. Oh my gosh. So let's figure it out. So we have 10 times 365 times 2 times 7, and we get $51,000. $51,100. Okay, 50 grand. You paid for that. That's an investment. That's what that is. $51,000. So what I want you to do is well, first of all, I don't want you to start smoking. But what I want you to take from this is that when you're problem solving, if you own the problem, if you somehow take control of, I am going to do this problem, and you don't get scared of it. I'm thinking the best word is you take ownership of the problem. You really take ownership, and you say, I can do this. And it's that mindset, that attitude that makes things easy. But if you try to attack every problem like you had to memorize certain steps, that's the wrong approach to take. Yes, there is some memorization required. You had to memorize the conversions. If you didn't memorize those, yes, it's impossible. Of course it's impossible. But then again, if you didn't memorize, if you were not told that each cigarette contains 15 milligrams of tar, you might think, well, how am I supposed to know that? Well, you look it up. you got the internet right next to you. You look it up. Find the average amount of tar for each cigarette. Type that in and look it up. So you have no excuses. So work diligently, and good luck to you.